So I should make a new function for message here. Pull message, function new. Let's say user and oh dear, for some reason my stream just cut out. What happened? What happened? Did it break? Something break? Or is my phone just not working? One moment. One moment while I figure out what just happened. My stream just broke. Why did my stream break? Why is my stream broken? What? No, it's not broken. It says I'm live. It says we're good. All right. Why did my phone, my monitor here cut out? Oh, there we go. We're good. Okay. I think everything's all right. I don't know why my monitor cut out, but we're good. Okay. Back to it. All right, message, new, return self, new message. It's going to be, this needs to have some text. Text, string. Okay, it's going to be from some user. Just make a copy of that. And I'll have some text. Text to string. Just like that. Yep. Expected one parameter. Message, new. It's going to be from. Should be from Alice. Hello, Bob. Something like that. Immutable borrow occurs here. Immutable borrow later used here. Send. Why is that happening? What's going on? I don't understand. Why that's happening. Chat server, add client. Cannot borrow as immutable. What? Why does it not let that? It's very strange that this is not allowed. So what is happening here is, so add client takes a mutable reference to self of this chat server, which makes sense because I am modifying the underlying chat server. Now, send is not mutable. Like nothing's changing here. This is an immutable function call, but for some reason, because it's borrowed mutably, this chat server is borrowed mutably here. It won't let me call an immutable method here. Oh, no, I see why, sorry. Alice is a reference, right? No, is that? Alice, Bob, mutable borrow occurs here. Immutable borrow later used here. Immutable borrow occurs here. Cannot borrow chat server as immutable because it is borrowed as mutable. The variable was borrowed as mutable more than once. Erroneous code example. Cannot borrow, yeah. Have many immutable references or one mutable reference. Take a look at. All right, so I think I can work around this by just oh no, I can't do that. I need to like release the borrow, or I think I can just make this mutable. Does that work? No. See, if I comment that out, then it's fine. But if I leave this in, it's no good. I'm not sure right now what the right way to deal with this is. Can I borrow chat server as immutable because it is also borrowed as mutable? Okay, I get it. I get it. I think it's because of the reference here. So, let me change the code a little bit so that when I do this message, I'm just going to put the name in here, so I'll just use a string. So this is kind of cheating, but it'll make it work. And this doesn't really need to be anything special. Right, it should be from. There we go. All right, That made the compiler happy. Now we're good. Okay, so send, yeah, that should be it. Now if I run this with the output, I should see my message. Why don't I see it? Why do I not see my message from Alice? So clients, iter map, print line, cargo test. Whoops. I just undid the wrong change. Whoops, got overzealous with my undo. Why is it not printing? So clearly I've done something dumb here. What have I done? User name. See what Clippy's complaining about. Unused inner map that must be used. So filter out all parity for every client. This should filter out clients where the user is not the same, and then map that. Maybe I should use for each on this instead of map. That's probably make more sense. Oh, there we go. Okay. Alice. Hello, Bob. Bob. Hello, Alice. There we go. Really simple chat server. I think I am satisfied with that. Let's copy this code and paste it into main to make Clippy warnings go away. Check what Clippy has to say here. I can just delete these because I don't need them. Boom. That's it. Let's check that in. Git add, git commit. Chapter 7, problem 7. Let's push that up to GitHub. All right. Let's see what's next. See what's next in the book. The next problem is called Othello. Possibly referring to Shakespeare. I think that's Shakespeare. Character from one of his things. Let me look it up. Let me look that up. I haven't even read the problem yet. Yeah, the tragedy of Othello. It's a tragedy by Shakespeare, believed to have been written in 1603. Fascinating. Okay, back to the code. Let's get back to the code. Othello. Othello is played as follows. It says, Othello is played as follows. Each Othello piece is white on one side and black on the other. When a piece is surrounded by its opponents on both the left and the right sides, or both the top and bottom, it is said to be captured and its color is flipped. On your turn, you must capture at least one of your opponent's pieces. The game ends when either user has no more valid moves. The win is assigned to the person with the most pieces. Implement the object-oriented design for Othello. Okay, is this a real game? Is this a real game that people play? Othello game. Oh. Oh, Reversi. Reversi was most recently trademarked by Mattel under the trademark Othello. Othello is one of the Reversi variations. Game Reversi was invented in 1883. Huh. Okay. Rules. Each of the discs, two sides correspond to one player. Light and dark, yada yada. The historical version starts with an empty board, and the first two moves by each player are in the four central squares of the board. The players place their discs alternately with their color facing up, and no captures are made. The player may choose to not play both pieces on the same diagonal, different from the standard Othello opening. There's also possible play, blah, yada yada. Okay. After placing the piece, dark turns over. I don't know if I fall. I don't know if I understand. Let me read what it says in the book again. Pieces placed. Each piece is white on one side and black on the other. When a piece is surrounded by its opponents on both left and the right sides, or both the top and the bottom, they're said to be captured and its color is flipped. On your turn, you must capture at least one of your opponent's pieces. The game ends when either user has no more valid moves. The win is assigned to the person with the most pieces. So, okay, so everyone, you get one move, and you're trying to flip the other pieces, and you flip the other pieces by placing a piece on either on other opposite sides, like top, bottom, or left or right. Right? I think I understand it. Implement design for Othello. So basically you have a board, some like n by n board, and you are able to place pieces in that board and if your move results in a piece having being surrounded on both sides, then it flips. Okay, got it. I think I understand. So this is not really that different from the puzzle implementation, actually, that I did before, but the game's a little different. The rules are a little different, but algorithms kind of similar. So let's copy the last problem, copy, paste. Now I have problem 8, problem 8. Delete all this stuff. Delete all this stuff. Let's call this Othello. Othello, that's an awkward word to say. Othello. I find myself having difficulty pronouncing that. I feel like I'm saying it wrong. Okay. Othello, 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 Othello. I feel like I have a lisp when I say Othello. Othello. So, okay, so there are some squares, and each square has a state. Let's just call it state, or yeah, let's call it state, and the state can be either black, white, or empty. Yeah. Let's implement clone, copy, debug, partial, equal, and equal for that. Yeah. Cargo test. All right. And then we have a board. A board. Struct board, and a board will consist of a two-dimensional array. We'll just call these squares, which is a two-dimensional array or vector of which each square has some state assigned to it. Yeah. Okay, let's implement clone and debug for that guy. Sweet. So that compiles. Okay. So let's construct an empty board. Let's implement that. Impl board function new. Let's return self, and it's going to return a new board with some empty squares that is just going to be constructed with a vector, or rather let's use vec with, how big is the board? It's 8 by 8. So 8 vectors with state empty times 8 times 8. That should be an 8 by 8 board. Yeah. Sweet. That worked. All right, that's cool. The vector macro has this way that you can construct n numbers of the same thing, where you specify the thing, whatever you want constructed, and then semicolon, and the number of them. So this gives me an 8 by 8 two-dimensional board. Yep. 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 Okay. Yep. 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 It's one of the best Muppets. All right. Let's take a couple-minute break. Five-minute break. Come back and continue. I'll be right back. Thanks for tuning in. Hope to see you again in the future. Maybe in 5 minutes, that would be cool. Or another time, you know.
9, 8, 7, 6, 5, 4, 3, 2, 1.
think it was muted. There we go. Unmuted. Welcome back. Back from a little break. We're here. We are cracking the coding interview. Doing the book. Going through the book. My name is Brenden. Thanks for tuning in. Welcome. I'm an internet person. Somehow I describe myself, I guess. I live here in New York City, which is a place on planet Earth. Pretty similar to other places, but also different in some ways. Yeah. All right. It's a nice day today here. Feels like spring has sprung. I think it's officially spring now. It's weird that there's an official spring, as if someone can just decree it's like, today is spring. I think the reality is that nature decides when spring has sprung. So get out of here with your rules and stuff. Okay, we are implementing Othello, a game. I was eating some nutty bits. A little bit of I'll show you a little bit of Trader Joe's mixed nuts. They're the fancy. It says right there, it's fancy mixed nuts. It's good stuff. There are nuts from Brazil in here, which is pretty cool. Drop some on the ground. Let me pick that up. We try to run a tight ship here. Try to keep a place tidy sometimes. Okay, enough about my nuts. Let's talk about computer code. Black, white, empty, those are the possible states. And we've got a board. We've got an 8x8 board. It's pretty basic. Let's construct a board and then just print it out right now. Let's see if we can do that. Let board equal board new. And then let's print the board. All right, Doge, what do you think of that? Doge is just hanging out, just having a good day. Just pretty happy. Having the time of her life. All right, there is our board. Now we need to initialize the game, and I believe to start the game, the first 4 pieces go in the center in a standard diagonal pattern rather than being placed by players. So, okay, so it'll be white, black, black, white. Got it. So let's make this a mutable board, and then let's add a new function here, which will be board.startGame. We'll say start game function start game. That will take in a mutable self. Doesn't need to return anything, and all I'm going to do here is change the board pieces. So basically I'll be so at 3, and these are 0 indexed. So I'm counting, it's going to be like 0, 1, 2, 3, and then 0, 1, 2, 3. So it's going to be 3, 3, like this, 3, 3. We're changing this to be state black. Okay, we have one black one. And then let's just do the two black ones with white first. They're diagonal, so it'll be 3, 3, and then 4, 4. And then we have 2 white pieces like that. So 4, 4 is going to be, oh, I'm doing it. doing it backwards. Should be the other way around. This should be white, and this should be black. All right. So yeah, 3, 3, and then this will be 3, 4. Whoops. This will be 3, 4, and 4, 3. 3, 4, and 4, 3 are black. Whoops. This should be self.board. Sorry, self.squares. There we go. There is my board. Start the game. We should have white and black there and white and black there. All right. All right. So to play the game, a player will place a piece on the board. We'll say place piece, and the piece is going to have some state. We'll just say state, and then I'm just going to say X usize and Y usize. So basically just coordinates. All right, self squares X, Y equals whatever that state is. That's it. Assign the state, right? So players take turns, they place pieces, and this needs to have a mutable self here. Players place pieces, just like that, one after another. And the next thing that needs to happen is that we need to check basically check if for that piece that was placed, are there any pieces that need to be flipped? So what do you call that? Check for check if captured. Okay, takes mutable self, and then the X and the Y. All right, let's do that here. We'll just call, after the piece is placed, we'll just call check if captured. Self, check if captured, X, Y. Right? So let's talk about how this algorithm will work. Let's switch over to the pad here, Steve Jobs' machine. All right, let's close this guy. Let's make a new one. How will this algorithm work? All right, so let's see. So imagine this is our board, right? And we have got a piece here, we got a piece here. I should do these in the right color. So let's say we got black here, and we've got black here, and then white here and white here. right? That's not exactly what the board has, but it's close enough. Whatever. Did I do it that way or did I do it the other way? Yeah, I did. I have it backwards. Whatever. It doesn't actually matter. Okay, so black and white. All right. So let's say the first move is to go here. Put another black piece here. So I place a piece there, right? And what needs to happen now is like this guy here is captured. This one here needs to flip to black. Right? So this guy becomes black. Now, what is the actual algorithm for that to make that happen? All right, let's just erase this stuff. This is fun. Fun having a little pen guy, little pen buddy, little pen friend. Good times. It's fun. Okay, figure out a way so that I can look in the camera while I'm drawing. I'll try. I'll just try. I'll try my best. All right, so let's do this again. So I got a black one here, and a black one here, white one here, white one here. This guy's not a circle. Now we got two circles. Let's try this again. Circle, circle. All right, close enough. They're different sizes, but whatever. Right? Looks good. Okay, so let's say white comes along and white places a piece here. So we placed a piece, and this is our board. And we know that the last piece was placed here, right? At this location. Right here. This is the last piece. So the algorithm is going to say, okay, I need to look in all directions. I need to look left across two spaces, right? So like one space here, two spaces here. Let's do that. So like, you know, imagine there's a space here and a space here. So I gotta look left when there's a space here and there's a space here, there's a space here, space here. Let's say there's no room to the top. So it's gonna look left, it's gonna look right, there's nothing there, it doesn't matter. Okay, and then it's going to look down, and you're gonna look to the adjacent, and that should be the opposite, or that if that is the opposite color, and then if also there's a piece one away, basically, in that direction, then that means this guy here, this guy gets flipped, right? Be doing a flip. So it'd be like, flip, flippy dippy, flip a doodle. Does that make sense? I think that describes the algorithm. Let's write it up. Let's write it in the code. All right. Put the iPad over there. Let's do it. Check if captured. So we're gonna look in all the directions. I don't know what happens at the edges, but generally I think I'm just gonna ignore pieces that might lie on the edge. Yeah, okay. So we've got up, down, left, right, yeah? let's add another function here that's going to be check if captured. I'm just going to call it inner. And this is going to just take self x x usize y usize and no, you know what? I'm not gonna add that function. I might add it. Let's just do it like this. Okay, so up here we'll say if we're looking up, then x needs to be greater than 1, right? So if let me just rename this function as well from if to for check for captured, sure. Check for captured. So if x is greater than 1, then I'm going to look above. So if self dot squares if self dot squares, and then it'll be so to look up it'll be x minus 1 and y. Self squares x minus 1 y is not equal to current square and the square above that minus 2 is equal to the current square. So if both these conditions are true, I can just combine this into one if statement. Okay, so if that is true, then this square here gets flipped. All right, this one becomes this, like that. So that is up. Now let's look down. So if x is less than let's do self.squares.length minus 2. Okay, and then self squares x minus 1. This is going to be plus 1, and then x minus 2. This will be plus 2. And then this should be, sorry, this should be x is greater than the length. Yeah, okay. Yada, yada, yada. Okay, then x squares plus 1 becomes that, right? That is down. All right, let's copy those patterns, but do left and right. And it's going to be y instead of x. So if y is greater than 1 and x, and then y minus 1, yeah, and then x and y minus 2. Here we start RLS. This will be y minus 1 equals whatever. So that guy gets flipped. Right? Okay. And then, okay, and then if y is, change this to y plus 1, change this to, sorry, not y plus 1. Oh, yeah. What? Plus, yeah, y plus 1. And then this to y plus 2. This becomes y plus 1. This is just x. Yeah. Believe that is basically it. Up, down, left, right. Those are the only possibilities, right? So you place a piece on the board and you check if they should be flipped. So let's test this. So we have a board, print board. Let's just put some checks in. Is there a way to? Yeah. Let's. I want to count. I want to like count by. So does Rust iterators have like a map reduce? That's what I want. Maybe not. There's a map. Oh, fold. Okay. Yeah, I guess I can use fold. Makes sense. Let's not do that right now. Let me just hard code the pieces that I know I expect to be there. Okay. So assert equals board.squares. Let's just say 4. I know 4, 4 should be 4, 4 should be, no, 4, 4 should be white. 4, 4 should be white. 3, 3 should be white. Right? Yeah. And then 3, 4. And 4, 3 should be black. 3, 4. 4, 3 should be black. All right, that passes. So let's place a piece. We will place a white piece. We'll say board place piece. We're gonna say it's white, and we are going to put that at 2 and 4. All right, and now these values are going to change because we're going to flip one. Whoops, and we'll have a new piece. So we're going to have a new piece, which is going to be a white piece at 2 and 4. And one of our pieces, which used to be white, is now going to be, or used to be black, is now going to be white. And that is the one at 3 and 4. Yeah, this one. This should be white, right? Oh dear. What did I do wrong? Let's look at the board here. All right, so I'm simulating, I'm putting a piece at, so this will be 0, 1, 2, and this will be 0, 1, 2, 3, 4. 2 and 4, right? Yes, that's what I have. So that should flip the piece at 0, 1, 2, 3, and 0, 1, 2, 3, 4. 3, 4, right? 3, 4, yes. But it is not flipped, which means I must have a bug in my algorithm. So let's print these out. And print out my boards. so I can see it. Print my squares. See if I can figure out what's going on. Oh yeah, this is gonna never make it. All right, do that again. There we go. So everything's empty except we have white and black here and black and white there. All right, and then here we have black and white. Then there's a white there which it placed, and then white and black. So it's not flipping it. And why is it not flipping it? Presumably because there's an error. So in this case, it should be looking down, right? Okay, so if I think I have my logic mixed up here. So if we're looking up, we're looking down. It should be this case. Let me just see what's happening. So it should be x plus 1. Right? No. No. What's wrong here? So 3 and 4. I'm putting this at 2 and 4. So the one that should be getting flipped is at 3 and 4. So that would be, so down should be x plus 1. Yeah, also I see another issue in my logic here. This should be, rather than doing this check where it's like equal or not equal, I should be comparing to the opposite, which is not the same because there's empty here, right? Not equal is not sufficient. So let me add a function here for opposite. I'll say impl state is opposite. This would be self, and then other. And then I'll just say if self is equal to, if it is equal to black, then that means I'm going to return other is equal to state white. And then if self is equal to white, return other is equal to state black, else false. This should return a Boolean. There we go. Okay, so here I would say if Iterator is opposite of that guy, and if Iterator is opposite of that guy, is opposite is opposite, right? Same here. Oh dear, these should be not opposite. Hold on, I'm gonna go back and fix these. I just copy this. Bear with me, please, while I fix all of these. It should be not opposite. It should be not opposite, not opposite, not opposite. And this takes a reference. Reference, reference, reference. Okay, it's still failing. But I think we're going in the right direction. Right, okay, so check up, comparing, so if x is greater than 1, that means like if x is at least 2. Maybe I'll write greater than or equal to 2 just to make it more clear. And then this one should be less than or equal to. If x is less than or equal to, I think this should be less than, just less than, yeah. And this should be less than, should be greater than or equal to 2. There we go. That's probably what it was. Boom, there we go. All right. I think that's basically it. Now, how do you know when the game is over? I guess I should implement a function. The game ends when either user has no more valid moves. The win is assigned to the person with the most pieces. All right. Let's go ahead and implement a function that specifies who won. Let's call it, excuse me, let's call this game result, and we'll have winner, and that will be just one of the pieces. I should rename state. To piece or something. Yeah, let's do it. Piece. Piece. Okay. Piece is not a good name either, but I think it's better than state. All right, so the winner, which piece, which color won? I don't want to use color because that's maybe a trigger word. I'll try to keep my jokes like that to myself. I don't think anyone finds them funny. Okay, the winner, and then let's say black pieces, or black count, I guess. Yeah. And that can be what, U size, or let's just do I32 and then weight count I32. Let's go ahead and say add a function that says it's called get result. Okay, for the game, and this will just always turn a result, a game result. Right? And the game will have been won when there is a game result that is one color or the other, right? So let's count, basically just count the pieces. Yeah. Let's look at the Iterator documentation. So I'm only using a flat map here because I want to flatten a I want to flatten out my array, right? Okay, let's do this. So self squares, iter, flat map, and we'll go square. Or rather, I can just do a flat map, and then I want to do a zip on that. No, sorry. Fold. I want to do a fold. Now I want to do better than a fold because I need to group by a particular key. I'll just iterate twice. So I'll do a flat map and then I'll do a filter. I'll say filter on each square. We'll say let black count equal self squares iter filter map filter square equals black. Okay. And I just want to count. Right? Will that work? Does that work? That does not quite work. Expected one parameter. Why do I need a parameter? Flat map s flat map creates an iterator that works like map but flattens nested structure. The map adapter is very useful, but only when closure argument produces values. If it produces an iterator instead, there's an extra layer of indirection. Right. Can I just return an iterator? Iter. Will that do what I want? Why does that not? No implementation for There we go. Okay. I just need to return the game result. So black count, white count. Let's do white count. And then we'll say winner equals self.get winner, which doesn't yet exist yet. Let me implement that next. Say get winner self and this will take in, I don't know. I'll just do this here. I'll say let board empty equal basically this, except I want to see if that's equal to 0. So that the count of empty spaces is 0. That means the board is empty. So then if the board is empty, I'll just say let winner equal if board is empty, else none, like that. Okay. If the board is empty and black count is greater than white count, then black. Else if board is empty, then it is white. There should be one more case where there's a tie, so I'll just put and white count greater than black count. I remove this. Let me change these guys to usize like I thought I should have. Sorry, not none, it should be empty. There's no get winner. Boom. Well, that's it. So let result equal board get result, and that should be that. Basically, we're done. I remove these asserts from main. Just need to call these functions to make all the warnings disappear. Cargo format, cargo clippy. Consider passing by value. This argument is passed by reference, but it would be more efficient if passed by value. All right. Do what you say, boss. Oh, thank you, Zed Tesla or Z Tesla. I appreciate the kind word. Do you drive a Tesla? Do you have a Tesla? Or are you a Tesla fan? Does it have nothing or anything to do with the car, or is it completely unrelated to the car? Cargo Clippy, cargo format, cargo test. All right, cool. That's it. We're done. Let's add that problem, push it up to GitHub. What time is it? It is 5:30 here in New York. Let's see if I have one. If I have enough steam for one more problem. I'm gonna read the problem first, see what it is, and maybe we'll keep going. Let me add this problem first. Git commit. Doing a cheat on Rust. I am going through this book here that I have, which is called Cracking the Coding Interview, and I'm doing the problems from this programming book. And I'm doing the problems in Rust. That's what I'm doing. So we are on chapter 7. The next problem is problem 9. Let's read the problem. I'm going to read the problem and then decide whether I want to keep going. I may stop. It's called a circular array. Implement a circular array class that supports an array-like data structure which can be efficiently rotated. If possible, the class should use a generic type, also called a template, and should support iteration via the standard for blah 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 notation. Okay. Basically like a circular buffer. An array-like data structure which can be efficiently rotated. What does that mean? To rotate an array. Circular array. I would like to know some more specifics about what is being asked. Like, what does it mean to rotate it? Data structures in computers don't exist in circles. Doesn't really make any sense. Except in the context of perhaps a linked list, but I wouldn't call that a cycle or circle. I would call that a cycle. You can have like a linked list that goes around. Let's go to the drawing board and think about this for a moment. Yeah. Okay. Let's close that. Let's make a fresh page here. All right. So, found me on request cheats Rust. Got it. I'm not sure how the word cheats got in there, but I'm talking specifically about programming in Rust. I'm not doing anything game specific, but yeah, I'm talking about programming. I'm talking about programming in Rust, and specifically doing interview problems, the kind of which you find in this Cracking the Coding Interview book. Just for your information, if you want to check out the code and follow along, you can go to GitHub, go to github.com/myname, which is Brenden. It's my name, Brenden Matthews, no vowels, and then go to /cracking the coding interview Rust with dashes in there, and you can take a look at the project. There it is on GitHub. There should be a link to this project as well in the description if you want to look at that. But in either case, welcome. thanks for tuning in. So let's see, what is a circular buffer? Let's think about it. So, like I said, data structures don't really work as circles, but I suppose you could conceivably have a data structure that kind of looks like, can be thought about as a circle where you have like 0, 1, 2, 3. This looks like a clock. Let's model it like a clock. Yeah? Right? So it goes around and around. So this would be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Although normally on a clock you don't have a 0, usually this is 12. Doesn't really make any difference. 12 and 0 would be equivalent. In fact, that's one advantage, I suppose, of treating this like a circular data structure, is that if you had an iterator, it would start here and it would just go around forever and ever. And when you get back here, you could just keep going and going around, right? And then it mentions in the problem that you could rotate it, right? Presumably that would mean just like shifting everything, but the indexes would stay the same, right? So like if I were to rotate this, really, like the only thing that would change effectively is that all of these would get renumbered. So after a rotation, this would become the new 0. Whoops. This would become the new 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, right? I think that's what it's implying. That's assuming the values change, right? So like you have two things here. You've got like the index and then the value. I'm kind of mixing these two up. But yeah, so like the item that would have been at 0 before, right? So I can illustrate it. Let me draw this again. Do it in a different color. Okay, so I have a circle like that. Perfect, beautiful circle. And I've got 0 index, 3 index, 6 index, 9 index, right? 11, 10, 8, 7, 5, 4, 2, 1. Sorry, 10, 11, something like that. And then on the inside, you would have values, right? So let's use different values. Let's just use a letter like A, B, C, C, erase. C, D, E, F, G, that looks like a 6, G, H, I, J, that's a 6 again, or a G, J, K, L, something like that, right? So then if you did a rotation, A would move from here to here. This will become your new A. And then B, go here. C, D, but the index values around the outside are staying the same, right? E becomes your new F, so on and so forth. So I think this is what the book is describing. H, I, J, K, L. Some sort of data structure that does that. So one Marco, yeah. So I think what you're getting at is right. Like realistically, you would not actually move the values around in the vector. You would just have a pointer that points to your offset, right? I believe that is the way to do this. And then when you go to rotate, in quotes, you don't actually move the data around, you just change the offset. I think that's probably the way to do it. Okay, this shouldn't take that long, so let's just go ahead and do it. Copy problem 8. The book is very vague on what it's asking for in this problem, so it's hard for me to really say, but this chapter is more about the object-oriented design aspect, since the name of the chapter is object-oriented design. So I think it's concerned mostly with how I design the interface rather than the actual code. So circular array. Implement a circular array class. So, excuse me, burp. Test circular array. Let's just see if this compiles. Cargo test. All right, we're good. So let's make a structure. We'll call it circular array. And it's just going to contain an array, which is just a vector. Let's make it generic. So I have sort of already forgotten how to use generics in Rust. Let me just look back at some of my other code, see what the syntax is like. Got it. Okay. So circular array of type T. That should compile. There we go. That's not being used anywhere. So what functions should I implement? Let's just implement the most basic. Let me just open up one of these guys again. I just want to look at the syntax because I'm going to, yeah, all right, impl for type T, circular array T. All right, function new, and yeah, new, just return self. This can just be empty. This can just be empty, like that. Okay, let array equal circular array, let's say of type character, new, right? There we go, that compiles. So let's implement a push. And how is push going to work? What does push do on a circular array? I'm not even sure. If your array is circular, then you would not have a push, you would only have an insert, right? which means, because assuming it's circular, then there's no start and there's no end. There's only a position. You could only have insert. And you could only insert somewhere within the array, right? Like if the array is 0, size 0, then you can only insert it 0. If it's size 2, then you can either insert at 0, 1, or 2. That is also true of any array, I guess. So that's not unique, but having like a push on a circular array doesn't, if it's really circular, then it doesn't make sense because you don't really have a start or an end, right? But okay, why don't I just assume that, hold on, I'm gonna just reread what it says in the book. It says, implement a circular array class that supports an array-like data structure which can be efficiently rotated. So all it specifies is that you need to be able to efficiently rotate it, which is, yeah, straightforward. It also says that you need to implement an iterator. So why don't we just assume that new takes in, let's say it takes in a vector of type t. So let's just say that it's like fixed size, effectively. Like I can't change the underlying vector. Let's just do that. Then that makes this a lot simpler, right? Okay, I need to pass in a vector here, and I'll just say A, B, C, like that. This needs to be a reference. Sorry, what? That should work. 2vec, okay. Clone not implemented for t. Where t std clone. All right. There we go. That compiles. Let's restart RLS again because it's not working. Got to do that a lot. All right. Cargo format. So we have an array. I'm going to implement a rotate, right? So we'll say function rotate, and it's a mutable function. So we'll have mutable self, and then some offset, which will just be a usize. So this is like whatever we want to rotate it by, and then we'll just say offset equals, or rather plus equals offset. Yeah, okay. Something like that. Not really sure if this is what the book was going for, but this kind of makes sense to me. Something like that. All right, and then next thing I need to do is implement an iterator, and I'm going to copy how I implemented an iterator from previous code here, and then just do this. All right, iterator for iter t item. Items just going to be t. Right. I'll just delete this code right now. Inconsistent type parameter. What did I mess up? I'm implementing for iter. Oh, whoops. I need to define, I need to like create a struct iter. I just closed the wrong problem. Let's go up here. So struct iter type t, and then next is just going to be a usize index, right? Yeah. Okay. What else? Cargo, unused type parameter. I guess this doesn't need a type, right? My iterator? Yeah, my iterator. No, my iterator does need a type because of what it is. I just don't need to use that type. Here. Hold on. So next would start at offset. Hello Gareth Hubble. Welcome to the stream. Thanks for joining us. Next, offset. Do I need that type? I do need that type. I need to have that type because I need to well, can I just do this? I need to return the value. Yeah, I can't do that. Oh no, I can do this. Yeah, maybe I can do this. One moment. Nope. Can't do that. Struct iter. Okay, maybe I have to use this std marker phantom data. I don't know how to use that, so let's try it. Hey, hello, Stir Y Cure. Hello and welcome. Let's use this phantom guy. Phantom data T. Could a quick tell you what I do actually? Well, right now I am working on a project here, which is based on this book called Cracking the Coding Interview. I'm going through the book and I'm implementing the problems in Rust. If you want to check out the project, it's on GitHub. You can go to my name, Brenden Matthews / cracking the coding interview Rust. There should be a link in the description if you want to check it out. We are implementing problem 9 right now from chapter 7. The problem I'm implementing is to create or design a circular array. That's what I'm doing. Okay. How do I actually initialize this phantom data thing? Phantom data. All right, that looks pretty straightforward. Sweet, it compiles. We're looking good. Okay, so iterator next should return some stuff. Okay, so I need one more value. I need a next, and I need a I'm gonna do this slightly differently. So next should be 0. We'll start it at 0, and then it will look like this. Here I will return. I'll say if cool. I'm glad you're getting some value out of the stream. Thanks for dropping by. And yeah, okay. So option item. Yeah, I agree. The best way to learn programming, anything really, is to do stuff. Is by doing. So if you're trying to learn, best thing to do is to just start writing code. I guess it's also valuable to learn from other people too. My suggestion to you, though, is to also try implementing the problems yourself. You can certainly use my code as like an example, or for reference or whatever. Like if you get stuck, you can look at it. Might be useful for you. Okay. Next, so if self in this case is the iterator. So right. Okay. If self.next is less than I need to, in my iterator, I need to keep a reference to this array. So here I will just say array self.array. Can I have a reference like that? Let's see if it lets me. It may not. Oh, I won't need this phantom data then if I do that as well. Why is it failing? I like half implemented some code here somewhere. Yeah, it's because of this line, I think. Expected lifetime parameter. I'm gonna need a lifetime on this. What is wrong? Oh. Undeclared lifetime. like that. Consider using the named lifetime. Where is that error? Error placing this struct. Consider using named lifetime. Oh, that should be here. I see. Here we go. Undeclared lifetime, 27. What? Am I doing this wrong? I think I'm doing that wrong. Expected lifetime parameter. That should be A and T. Do I need to put the same parameter in here? I think I must. Expected lifetime parameter. Yeah. Unexpected lifetime parameter. What? Cannot infer an appropriate lifetime. This should be A. First, the lifetime cannot outlive. Does not outlive borrowed content. Cannot infer an appropriate lifetime for a borrow expression due to conflicting requirements. I'm doing something wrong here. So the iterator, this iterator that I'm constructing should never live longer than the array, right? Expected, found. Can I not specify it like that? Expected. No, I'm doing this wrong. T. All right, hold on. Let me rethink this. I think I'm going down the wrong path here. Let's remove that for right now. Let's remove this. So I need some kind of reference to the array that I'm operating on. How does Rust Iterator Implementation, how, I wonder, do other people implement this particular part of the iterators? Self-current, self-next, current next. This isn't really a good example. That isn't either. Iterator, item. Okay, so iter new type. I see. Okay. this is what I was trying to do. I think I just did it wrong. Let me go back to what I'm trying to do. My type should look like this. I see. Okay, I wasn't that far off. And then here I want the array, right? Yeah, vec of type T, like that. I get it. So I think these lifetimes need to be separate. Yeah, Rust is very different from a language like Python. I'd say Rust has more similarity to a language like C or C++ than it does to Python. Mainly because it has strict typing, like it's statically typed and strongly typed, whereas Python is dynamically typed. That's the main difference. It's also a compiled language versus dynamically interpreted language. Okay. Then iter. Okay, so I need to specify lifetime here. Got it. I think I'll get it. I think I get it now. Iter, like that. And then array, self.array, like that. Right. Cargo test. Whoops. I did this wrong. Iter should come before the lifetime parameter there, cargo test. Lifetime already in scope. Okay, so I don't need that. There we go. All right, there we go. That compiles. So that does what I want. Now I can go and say if self next is less than array.length, then this is pretty simple. I'm just going to return, let's just do else like this, okay. And then here all I'm going to do is index the array, but I want to do next plus offset like this, and then I'm gonna just do the mod, or use mod on the length, right? Whoops, self.array, self.next, self.offset. Oh, I also need to increment next. So self.next plus equals 1. And then I would do self.next minus 1. There we go, like that. No field offset. Oh, this should be, this is in the other structure. I wonder if I should just, instead of putting the array in there, I'll just put this, we'll say, yeah, I'll just put this whole thing in here, right? Circular array. Okay. Like that. Basically just keeping a reference to the entire thing. which makes this a little ugly, but whatever. I think rather than using the square brackets, there should be a get function or something that returns an option on a vector, right? I think get, there should be a get. Yeah, get returns, get returns a slice index. I don't want that. I want get, but with the, just return the value. Or can I just change my iterator to return a reference? That would be easier, right? Okay. Then I could just do array.get like that. Okay, no, I'm not allowed to do that. Expected type, found type. So this is expecting an option of the item, but I want to return a reference. Where was that example of an iterator implementation that I was just looking at? This is a different one. I want to look at Rust iterator implementation. Iterator item. I want an iterator that returns a reference. Oh, okay. So I can just put that in. Got it. I see it. So I'll just put it on the type here like that. Yeah, let's try that. Cargo test. Oh dear. It does not have this field. I'm calling the wrong fields here somewhere, right? Line 28. I'm looking at the wrong code. Oh yeah. This should be circular array equals self, like that. There we go. Sweet. All right, let us go ahead and test this guy. So I should be able to do for C in array iter. Let's just test it. Print line. Character something C. And this should just print ABC. Oops, no capture. There we go, ABC. Now if I rotate it once, I need to make this mutable. If I rotate it, rotate by 1, and I do this again, then it should be off by 1. ABC and then BCA. Sweet. Well, I think we're done, basically. Not much else to it, right? Let me turn this into a bit of a test thing here. Let's go let test vec1 equal vec. Basically want the same thing. Actually, I can just do this. I can just say array iter collect, and then assert equals vec. So this should be A, B, C, like that. And then rotate, and it should be BCA. Why can't I do a collect on my iterator? Type annotations required. Collect. Okay. We'll say let result one of type circular array character equal that. Or rather, this is just going to return a vector, right? And then assert equal result one. Let's try that. A collection cannot be built from okay, does this have to be a reference? No implementation for let me change this to map these guys to, so each of these characters, I'll just dereference them like that. There we go. Okay, that's a bit ugly, but whatever. It works. And then check result 2. This should be B, C, A. Like that. Cargo test. Boom. All right. Let's check Clippy. Clippy has some suggestions here. Whoops. Let's apply them. Change this to blah 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 T. A slice of tea. I'll have a slice of tea, please. Okay, saying I should use cloned here. Cloned instead of this map dereference thing. Okay, fine. Makes sense. Yeah, if you have never seen Rust before and you are just just joining for the first time, then probably a lot to take on all at once. All right. Let me copy this code into main to make the error warnings go away. Take out the asserts. Just leave rotate. Maybe I'll add one of these in. Whoops. Clippy. All right, there it is. That is our circular array that I'm going to add. Very simple, very basic, not much to it. That should be problem 9. Let's commit that. Add chapter 7, problem 9. Yeah, circular array. That's it. Let me commit that. I'm gonna push that up to GitHub. That should start building, and that'll continue going, doing its thing out there in the code land, code world. So the next problem, I don't think I'm gonna get into the next problem because it looks like it's gonna take a while, and it's like 6:30 here in New York. It's kind of getting late, but here's the problem anyway. I'll show you. No, I'm not Gareth Hubble. Sorry if I'm pronouncing that wrong. I'm not Gareth. My name is Brenden. I'm different from Gareth. I'm going through this book, by the way. It's called Cracking the Coding Interview. It's full of some programming interview problems. Book's written by Gail Lackman here. She's a computer person who worked at Google at one point. Google's kind of notorious for their intense programming interviews, and so anyway, she wrote this book, and it's full of these programming problems, which are kind of fun to do. They're good practice, and for me specifically, I started doing them because I really wanted to learn Rust properly, and I thought this would be a good way to not only just like practice my skills, but really learn Rust. So anyway, we are on chapter 7. The next problem is problem 10. So chapter 7, problem 10. I don't think I'm going to start it, but I'm showing you the problem here anyway. It looks like, so it says design and implement a text-based Minesweeper game. Minesweeper is a classic single-player game where an n-by-n grid has B mines or bombs hidden, yada yada. Well, thank you for coming to the channel. Thank you for dropping by. It's a shame you're here kind of at the tail end, because I'm gonna shut things down shortly. But thanks for joining. I will do this problem next weekend, probably. I'll probably pick things up next Saturday and continue on Minesweeper. And you're asking why Rust? Oh no, you haven't scared me away. It's just bad timing. But you're asking a good question. Why Rust? Why Rust? Well, let me switch over to the pad here and talk a little bit about why Rust. So Rust was created to, I think, I'm not like one of the creators of Rust, but as I understand it, Rust was created to solve a few different problems. So one problem that the Rust designers wanted to solve was safety, right? And if you look at most really bad bugs, they tend to be things like memory buffer overflows, right? So if you imagine you have an array like this, these are just like cells, memory locations, okay? And then you have a pointer somewhere, and it's like pointing to something in the array. Everything's fine at this point, right? Where like you're pointing to like, this is like cell 0, and then this is like, I don't know how many that is, like 15, 10, 15-ish, something like that. Everything's fine as long as your pointer only ever, points to like one of these all the way up to the end. Now where most security bugs come from is most of the time it's some variation of the problem where you have some memory allocated like this, and you have like a valid memory, and then for some reason or other, your code tries to reference here, or tries to reference here, or tries to reference over here, or whatever. Or another very common case is that you allocate, you allocate this code, you do a malloc or something, and then someone comes along and they free this code. They're like, okay, well, or they free this memory. They're like, great, we're done with that memory. We don't need any more. We're done. It's all done. It's all gone. And then what happens, someone's like, oh, but wait a minute. I have a pointer and I want to access that memory, but it's been freed. This is called a use after free. So those are examples. I'll just like list that out. Safety, buffer. So like buffer, over, under, runs. Sorry, my handwriting is garbage. So trying to solve buffer issues. Another is use after free. So using a pointer after it has been freed. Another is dealing with initialized pointers. So if you have a pointer that is after free, uninitialized pointer. Also, this current pen is not great for writing. Maybe I should use a different pen. Let me try this one. I don't know if that's better. Well, anyway, try this one. Oh, that's better for writing. There we go. Okay. An evangelist. I'm not a Rust evangelist. I'm just interested in this stuff, and I've written like a few small things in Rust, but I only really got interested enough in Rust to like try to start teaching it to other people in the last couple months, and I haven't really used it that much. So, I'm still learning, but here we are. I think it's a cool programming language. I think that it's a programming language that people need, and yeah, I enjoy it. I enjoy writing Rust code. One of the reasons why I enjoy it actually is because it's kind of difficult. It's difficult because it makes you really have to like think about what you're doing. So the second big thing that the Rust designers wanted to do was make it fast, right? Fast in that it compiles to native code, and it uses LLVM under the hood, lower level virtual machine. If you're familiar with that project, there's a lot of languages based on LLVM now. Compiles to native code, and it has what's known as, sorry, that's not readable, or it has what's referred to as zero cost abstractions. Zero cost abstractions. And zero cost abstractions are just language abstractions, higher level abstractions in the language that let you represent some concept without adding overhead, right? Pretty simple. So there's a big focus on safety, on speed, performance. Like the language itself should be fast. I think another goal of the Rust project, another goal was to basically just like modernize things, right? When I say that, I mean I I think generally the programming world has, for one, moved beyond object-oriented design in general, and nowadays the stylish things are functional programming. I say stylish, I'm not necessarily saying that it's stylish in a bad way, but it's just like that. Currently, like, most people agree that functional programming is a good way to build software. Traits is kind of like an alternative to object-oriented design, which is, I think, a little better. It's effectively the same thing. It's just a different way of thinking about the abstractions, with arguably a little lower overhead, and helps you avoid certain types of like weird design issues, I guess. I can't really think of like a specific example right now. I mean, yeah, I think those are the main things. Let's see, what else can Rust do? I mean, Rust has a lot. It has other things it has are, let's see, like, what are some Rust features? My handwriting's so bad. Rust features. So I already mentioned some of it, but there are functional features. If you have used any decent functional programming language, then there's a lot of things that are really nice, right? So specifically closures or lambdas, you can call them, which is, closure and a lambda doesn't mean the same thing, but you can, I guess, I don't know, I tend to like use these terms interchangeably, I guess. But anyway, closures, lambdas. A lambda is just an anonymous function. A closure is also an anonymous function. How's the tooling world for us? Good question. Let me talk about some of the features. So there's functional stuff in there. I'm not even sure what the right word for it is, but like functions like map, filter, zip, what else? Fold. Like, these functions should all be built into the language, right? Any decent functional programming language you work with will have like a collections library that you can use with all of these, like map, filter, zip, fold, whatever, and you just end up chaining all of these different operations together, and it's a really nice way to deal with collections of objects. So there's that stuff. What else? So talking about the tooling, I mean, there's a ton of tooling stuff, but in terms of tooling, I actually wrote a blog post all about this, where I show that really quickly. I wrote this, I don't know, a week or so ago, week or two ago, where I actually just kind of went through a lot of these things, but one thing I talk about is the tooling. And Rust already, let me make this a little more readable. Rust already has a bunch of tools and features. Some of them are like part of Rust itself, the Rust language. Other things are just kind of separate packages on the side, but I'd say, yeah, I wrote this blog post for you. I'd say that like the Rust ecosystem is still growing. There's a lot of stuff. It's definitely not what I would call mature, but there's plenty of good stuff out there already. There's enough good stuff that you can generally be productive. So some of the things that I like about the Rust ecosystem now that already has is there's already a package manager. So package manager, which is called cargo or crates. Sorry, cargo is the command you run, but it's called crates. So you can go to crates.io and it's like a package index or whatever. So there's package manager. There's obviously like compiler and all that. There's something called RLS, which is Rust Language Server, and that's like IDE integration. So it works with like VS Code or whatever, and so on. Yeah, I mean, there's lots of stuff. Like I said, it's not as mature, but most of the things you'd expect to be there are there. Generally, there's like some things that aren't necessarily Rust specific. Like there isn't very good debug tooling yet. You can just use like regular debug like LLDB or whatever, but it's not. I wouldn't call it tightly integrated with Rust, or at least I haven't found it to be. But I also haven't really needed it, because the nice thing about Rust is that if all your code is safe, you almost never, well, not never, but you're less likely to need to use the debugger, because your code's probably not going to be blowing up randomly, and you aren't going to need to like jump in and start poking around and stuff. But anyway, I mean, this is not comprehensive. I'm definitely not a spokesperson for Rust, and I don't know all there is about the language. I'm frankly still learning at this point. I'm still learning about programming. I've been doing this for 10, 15, I mean, I've been doing it for 10 plus years professionally, and I guess I've been programming for like 20 years now, probably, and I still feel like I'm learning all the time. And if anything, I'm just starting to reach the point where I feel like I have a pretty good idea of what I'm good at and what I'm not good at, and where I need to get better. So anyway, there's lots to learn, and just gotta keep learning, always be learning. So anyway, yeah, if you want to check out that blog post, should be able to find it on Medium. Or no, sorry, it's on Hacker News. But if you just search for programming in Rust, the good, the bad, and the ugly, which I guess is kind of a cliche title, but does it show up on Google? I don't know if it does. Oh yeah, it's the first result. So if you search for programming in Rust, the good, the bad, the ugly, then it's the first result there. And yeah. All right. Rust considered harmful? No. Yeah, I mean, I tried to like provide a useful article, and I'm useful and balanced. Rust is not all good, but I think it is good. Like, compared to like the C++ ecosystem, like the state of C++ and the language design and everything, it's definitely not as troubled as that, I would say. Not that C++ is troubled, but it's just like it's it's just not a pleasant language to work with, and it takes a really, really long time for features to like get into the language and filter down and then actually be something that you can actually use. It just takes a really long time, and there's so much like legacy backwards compatibility stuff that's in there that just makes it not really that fun to use comparatively. You know, C++ is probably like the closest thing that you could really compare directly to Rust in terms of the problems it's meant to solve. I guess you might put Go in there, but Go is a little different for a few other reasons. Like for one, it doesn't have generics. It uses garbage collection, and the way it handles memory, well, you know, it's garbage collected language, so it's not the same. It's not really in the same class. It's not in the class of strongly typed with generics and with explicit memory management, right? All right. Anyway, yeah, I'm gonna sign off. Well, thank you for joining, everyone. Hello to my new viewers, and hello to everyone if you're joining from previous. I'm gonna sign off. I gotta take Doge to the park. Where is she? Hey, Pup. Hey, Pup. Come here. Say hi. You wanna come say hi? Come say hi to everyone. This is Doge. She's my little stream helper. Just give me a kiss. All right. I gotta take her to the park and give her some dinner. Thank you all for joining. I'll hopefully see you next time. Thanks for dropping by. Take care. Let me figure out how to turn this off. All right. Yeah, she's a good girl. She's spoiled. She's very spoiled. She knows it. All right. Bye-bye.